Here we have a sample problem on interference on films. Calculate the minimum thickness of a soap bubble film that results in a constructive interference in the reflected light if the film is illuminated with a light with a wavelength in a vacuum with wavelength of 600 nanometers. The thickness for a constructive wave is given by equation 5. We recall the equation for the wavelength as it moves inside a medium of index of refraction. Substituting this equation to equation 1, we get the value of the thickness of the soap bubble film, which is about 112 nanometers. In this case, we determine if there will be a constructive interference if the thickness of the soap bubble film is doubled. Doubling the thickness, we simply multiply it by 2. To determine if it has constructive interference, we determine the value of T for m equals 0 and 1. We see that for m equals to 0 is equivalent to the thickness T, and for m equals 1 we see that the thickness using equation 6 is about 338.3 nanometers. Since 225 nanometers is not equal to the value of T for m equal to 0 or 1, therefore there will not be constructive interference when doubling the thickness of the soap bubble film.